My name is Joe Keddie, and I'm a professor of soft matter physics here at the University of Surrey. And I'm also a Royal Society Industry Fellow. And as part of my fellowship, I'm spending 50% of my time with a small company called Pulpex. Every day, 1.2 billion plastic bottles are manufactured globally. And in the UK alone, 700,000 plastic bottles are littered every single day. So everyone wants a solution, no one wants to use plastic. But what's the alternative? I'm working with Pulpex, who have developed a paper bottle. And this is an alternative to conventional plastic bottles to hold liquids. It can replace things like PET, but it has 30% lower carbon footprint. So even the manufacturer of it is more sustainable. And importantly, this bottle can be recycled in the existing waste streams with paper. So there's no problem whatsoever in recycling it. And so in our work, we're looking for alternative materials so that if the bottle isn't recycled but goes into the environment, it'll degrade naturally. One of the candidate materials is called chitosan, and this is being made by a small company in Scotland. And this is a natural type of material that can be derived from crustaceans or shellfish. So in fact, their factory is located near a seafood manufacturing where they're processing scampi. So they can extract from the waste shells. Essentially, it's a type of carbohydrate material, which we're now developing as the barrier layer. And so things we're doing in our lab is investigating different ways of depositing the coating and also looking at its properties. So how fast does water flow through the coating? What can we do so it's even more watertight? And there's a researcher on an Innovate UK funded project in the lab, Solomon, and he's studying the transport of water through the chitosan and looking at different designs, because typically you don't put a single coating, but you would put multiple coatings as your barrier. It's also important to have the right mechanical properties. So if someone drops the bottle, it might dent, but will it fail? We need to make sure that if it's dropped or hit with something, that it won't start to leak. And so we're also looking at the mechanical properties. And in addition to the barrier layer, we're looking at other components that could be used. So for instance, adhesives that could be used to stick a label on, or adhesives that can be used to stick the cap on. So there's a PhD student named Grace in our lab, and she's studying the degradation of a new type of polymer that we've developed with some chemists here at the University of Surrey. And that polymer is designed to degrade when it's triggered in a certain way. The ultimate vision of our research is for us to walk into a supermarket and see these paper bottles on the shelves.